Now we're going to get into another part of building the stroker engine. A stroker engine has a different power band than your stock engine, and therefore it will not work with your stock gears. Not very well, because the power band and the gear ratios are different. Now this is the back of your transmission case here, the underside of it, and these are the stock parts that are in it, except for these two tools which I use to pull this main drive through the case right here. What we have is, let's see if I can remember this right. I believe this is your primary gear here, and here, and this is your secondary. Now, in order to change your gear ratios, most kits that I have seen will give you a little bit different drive shaft with the larger teeth on it and a little bit smaller ring gear. And that's all you get. But you can also mix and match different gear ratios by changing the gear on this shaft, which it will come off, but you need like about a 1,000,000-ton press to get it off. They're very hard to get off, and they do make a different size shaft there. Now there is a code on the internet somewhere, I have seen it, which if you'll put in the diameter of your tire by the circumference, by the number of teeth in the gears, you can actually figure out your top mileage, miles per hour. I haven't been able to find it, and I'm no good with geometry or trigonometry, so come on. Now, here's where we do our changes. This is your stock input shaft right here. This is your stock secondary gear. This is the gear that will allow you to do about 60 miles an hour. If you'll notice, the racing gear here has a little larger diameter teeth spool than the stock. And also, the secondary ring gear has less teeth on it. Now, I don't know how that extrapolates out to being faster, but it does. In order to run a stroker motor right, you've got to put on this and this into your transmission case, and a lot of people have said, well, oh my god, I can't do that, it's a transmission, blah, blah, blah. It's easier than breathing air, and I'll show you how to do it. I can't give you the transmission codes, because that I don't know. Now, the only hard part about this is that this is like a crankshaft right here. Your main bearing that I showed you earlier rides right on this shaft. The bearing, this shaft is tapered from here to here a little bit larger than right here. You can't tell. But as you put this through the bearing into the crankcase, and this part hooks onto your clutch. Now, if you look over here on this is a virgin one. It hasn't been used. This is a race one here. This is your stock. If you look right here, you'll see a little line right there. That's where your bearing rides on. And this shaft will drop right into that bearing, except for that last ½ inch. That's where it's got to be pulled through the bearing to make it tight. Now, this is an example of something that I got from VT Cycles. And this is where I'm lost in this, but I tried it, but I'm lost in it. This is your secondary or final drive. I'll call it final drive gear. Okay, now this is a racing final drive gear that you can buy. I don't know how many variations or how many teeth you can buy. This is your input shaft, which is stock. This is stock, this is stock. Now if you'll notice that this gear, it looks exactly the same, except it's got wider diameter teeth compared to the stock. It also has the racing gear here has less teeth than the stock one. Now all that extrapolates out into revolutions per minute, top speed, and I haven't been able to find the exact code on it. In order to get this shaft right here off this gear, you need to take this gear down to a machine shop, have them put it on their big giant bearing press. It's got about 1,000,000 pounds of torque on it, and it'll pop off. And then when you go to put your new gear on, you're going to have them press the gear on. And you can see that's where the gear is popped off. So this is just one of my experiments I was trying. Now here's your stock case on the inside. It should be clean. Here is the bearing I discussed that will go right here. What we do is we take the very tip of the shaft and we put it in here, like right here. This fits on your clutch. This fits on your gearing inside the case. So we put the shaft in here on a bench, and then we have to pull it the last half an inch. Everything else will just set in there. You don't need to even worry about it. You can even pound it in if you want. I mean, if you don't have the tools. I mean, it can be done. Remember, we're not working on the space shuttle or Ferrari. This is a glorified weed whacker engine, so you can cheat a little bit. Now here I've got a Kleenex box, and this is to show you how this works. This is the racing gear. As you can tell, it's got a bigger head on it, and it's also virgin right there. And it started to pull through the bearing. There's a bearing right in there. You can see the bearing, and I usually put a new bearing in just to make sure. So, and this works just like my crankshaft deal. What we have to do is pull the shaft just this last half inch through the bearing to make it seat right. In order to do that, we take the crankcase tool, the long one. It fits on the small side, and it fits on this too. Now also, this sleeve works excellent against this. So we do the same thing. We take the sleeve, and there's an upper view of it. We'll take the sleeve like we have here, and we'll put it down on the we'll slide it down the shaft, and then we hold this part stationary, and we turn the knob. I believe it's clockwise or counterclockwise. It works backwards. As we turn this knob, it pushes, or bolt, nut, it pushes the extender down into the case, and what it does is it slowly pulls the gear into place. And all you have to do is be very slow about it. And as you can see, I've almost got it pulled all the way through right there. All I have to do is pull it another 1/8 of an inch, 3 millimeters, and it'll set. Once it's set in there, it's done. And you'll be able to tell because you'll go to twist on your crescent wrench and you won't feel it anymore. Now here's another shot where it's almost seated, but that is not seated yet. Now here is a shot where the gear is fully seated, the input shaft into the bearing. All you have to do is take off your tools, and it's done. Now what we do is we rebuild the rest of this. There is like a plastic thrust washer here, stainless steel thrust washer there, and here is your racing gear right down here. That shows you another view of how it's done. And we'll go on to the next video.